In section 3.2, I kind of skipped over the whole addition and subtraction of decimal numbers. I assumed that you're allowed to use calculators, so you might as well use it. You could say the same thing about multiplication and division, but I feel it's worth kind of showing what happens, because some people are things they don't expect would happen here. So if you think about this number 5/10, the reason we pronounce it as 5/10 is because, well, 0.5, 5/10 here, is exactly the same as 5/10, 5 divided by 10. It turns out dividing by these powers of 10 is what we call them. Dividing by those powers of 10 just end up moving the decimal place around. So if we have a 5 and divide by 10, it's just like having a 5 and starting out with your decimal place here and moving it once to the left, so we end up with 0.5. This is why the place values are things like tenths, hundredths, thousandths, because those are powers of 10. 10, 100, 1,000, so on. You can see the same thing happens here. 1.4, you could actually do the same, well, exactly what I just showed here. 14 divided by 10. Well, I'm dividing by 10, and we're starting out with the decimal place to the right of the 14. If we, when we're dividing by 10, we move the decimal place one place to the left, which gives us 1.4. So 1 and 4/10, you could actually think of that as 14/10. And so that actually, this gives another way of writing these decimals as fractions, just by kind of leaving the decimal place out of there. So you can see there's a 1 and a 4 if we just ignore the decimal place, and then doing the denominator to make the correction for where that decimal place should end up being. Alright, so in any case, I was getting a little bit sidetracked there. The reason I'm talking about these is because what happens when we multiply 0.5 times 1.4? Well, what we can do is we can go back and we can rely on their fractional forms. This is the whole reason I gave the fractional forms here. And since we've already seen how to multiply fractions, we would just do it that way. 5 times 14 is 70, 10 times 10 is 100. So we get 70 over 100. We can do the same sort of trick, except 100, to divide by 100, we move the decimal place over 2 places. So we start from the right of 70, we move it 2 places, we end up with 0.7. You can see that's what we get there. Now, this kind of hopefully should be fairly straightforward. You know, I did this in more steps than you would really feel necessary, probably. Just because if you think of this 0.5 as 1/2, of course, a half of 1.4 is 0.7. So you can kind of intuitively see that that does end up working. But this process right here, converting them to fractions, multiplying them together, and then basically moving your decimal place, the correct number of places back, is if you were multiplying these things by hand, this is how it works. So if we had 0.3 times 0.2, well, first off, ignore the decimal places. 3 times 2 is 6. But I had to, in order to think of those as whole numbers, I would have to move the decimal place 2 places to the right, which means when I take that 6, I need to move the decimal place 2 places to the left to get back to the actual number that I should have ended up with. And so this is the perhaps surprising part for a lot of people. If we take something like 0.3 and multiply it by 0.2, we actually get something that's quite a bit closer to 0. And what you end up seeing is that whenever you're multiplying numbers, let's think about a number line here. Here's 1, here's 0, here's -1, we have -2 over here, and 2 over here. If you're multiplying by something that's bigger than 1, so this stuff over here, or less than -1, then when you multiply a number by one of these, something in one of these regions, we end up getting farther away from 0. And most people think of multiplication as getting you farther away from 0. If you're taking 2 times 3, you know, we end up with 6. So you can either say, okay, well, you know, I'm twice as far away from 0 here, because, you know, I was at 3, now I'm way over here at 6. You know, way over there, wherever. And you could think of it the other way as well. I was at 2, and I end up at 6, however you want to think about that, because they're both outside of that range, you know, in this range I just described there. But it turns out when you multiply things that are within this region here, you actually end up getting closer to 0. So if I was to take, I don't know, 7 times 0.5, 0.5 again being between 0 and 1, it's in this region, you know, this is half of 7, which is going to be 3.5. And that ends up starting us over at 7. We end up getting at 3.5. We're getting closer to 0. So, you know, multiplication doesn't always get you farther from 0, I guess is what I'm trying to say there, in a very long-winded sense. All right. For these ones, I don't know that it's really necessary to do these by hand. I would say probably just pull out a calculator and do them, and that's what I'm going to do now. So if we take 2.5 times 0.6, you know, we get 1.5. You'll notice if we're thinking of starting at 2.5, we end up with a smaller number, something closer to 0. So we get 1.5. And I could have done that using this same technique I was describing up there. 25 tenths, because in order to count that as 25, I'd have to move the decimal place over one place to the right. Same thing, same kind of thing goes here. I'd have to move the decimal place one place to the right to think of it as 6. And 25 times 6 gives me 150. So I would have 150, and 10 times 10 is 100. Dividing by 100 is going to be the same as moving my decimal place 2 places to the left. We get 1.5. So you can see, of course, I already did it here with a calculator. We could do the same thing here. 1/10 times 1/10. Each of these are 1/10. 1 times 1 is 1. 10 times 10 is 100. And this, we'd have to move the decimal place 2 places. We get 0.01. We get 1/100th. And I could do the same things with the rest of these. Now, with something like 2 times 0.003, so 2 times 3 thousandths, I wouldn't bother doing any of that. I would just use the fact that I'm doubling this to double each of the digits individually. And since there's no carryover, you know, we get 0.006. That's pretty easy. 14 times 8.4. Here we're multiplying by a power of 10, so I don't even feel the need to pull out the calculator. I'm just going to move my decimal place one place to the left here. We get 1.484. You can really save yourself... Oops, what am I doing? I'm multiplying by 10, not dividing by 10. I should be moving it one place to the right. 10 is bigger than 1. I should be getting something farther away from 0. Alright, so we get 184.4. There we go. I guess I do need to make sure I get the right answers on these, don't I?